So here we go. We're writing parametric equations in rectangular form. So we're doing what we said yesterday was kind of where we lose the information. If we eliminate the parameter t, that's when we get that like the sunscreen is related to the ice cream, and it doesn't necessarily make any sense, but it does put it back in rectangular form. So we're going to take the split up, more exact version and put it back together to make it into rectangular form. Okay, so to write parametric equations in rectangular form, you must eliminate the parameter t. So you want to think of these as a system of equations, right? It's two equations, it's three variables, but that's okay because we're not solving for an actual number, we're solving for a variable, so it's okay. And those of you that take the SAT, if you didn't know already, you probably should have figured out that the SAT freaking loves systems of equations. They love for you to set them up, they love for you to solve them, so you better learn to love them yourself to be able to do well on them. So it's telling us, but since we're solving for a variable and not for a value, then the elimination method doesn't work. So we're going to have to solve one parametric equation for t, and then use substitution. Okay. Our directions here say write each pair of parametric equations in rectangular form and note any restrictions in the domain. That's important. Okay. They may tell us restrictions. There may be restrictions that we have to catch on our own. So when I look at number 1, both of these are linear, so there's no domain restrictions at this point. I'm good. You got to check it out at the beginning and you got to check it out at the end. Which one you solve for t makes no difference. My suggestion is you just take the easiest one. So I would think this one would be the easiest to solve for t. So I'm going to add t to both sides and subtract y. So I will get t equals 6 minus y. Now that I have that, I'm just going to take this, substitute it in for t right here. This will give me x equals 4 times 6 minus y minus 1. So one thing I'm not going to do on any of these is distribute. I can, and it wouldn't make it wrong, but on some of the other problems, it's going to make it more difficult for me to finish the equation. So I'm just going to leave it like that and solve for y from here. So I would add 1 to both sides. Gives me x plus 1, not x plus 4. See, I told you. That's equal to 4 times 6 minus y. I now want to divide both sides by 4, but I don't want to put this whole thing over 4. So instead of dividing by 4, I can multiply by what? 1/4. So this will give me 1/4 times x plus 1 equals 6 minus y. I'm going to subtract 6 from both sides, so I'll get 1/4 times x plus 1 minus 6 equals negative y. I don't want negative y, so I multiply through by negative 1, and I'm going to get y equals negative 1/4 times x plus 1 plus 6. Then I need to look at domain. So there wasn't any domain restrictions up here. Down here, this is just another linear, so it's fine. I don't have any domain restrictions. Okay. Yeah, they went away. But sometimes when this goes away, because this is Wi-Fi and that back there is Ethernet cable, even though I lose them from here, they're still over there. But I don't think they can hear me, so I don't know. They can see, but I don't think they can hear. I can't. It's just a bad day for everybody, I think. Okay, so, oh, it went totally way over here too. Yeah, they're gone. I don't know. I'm going to solve this I'm going to solve the second one, I think, for t. I don't want to take the square root here. So this will give me y over 3 equals t. Then I'm going to substitute it in here. And this will give me x equals y over 3 squared plus 5. So I go ahead and square that first term, and I get x equals y squared over 9 plus 5. Subtract 5 from both sides. That's equal to y squared over 9. So then I'm going to multiply both sides by 9. Now get y squared equals 9 times x minus 5. Again, not distributing. I have y squared though, and I want y, so I'm going to take the square root of both sides. Since I'm doing that, what do I have to make sure I put? Plus or minus. and that's plus or minus the square root of 9 times x minus 5. Well, I can take the square root of 9, but I can't take the square root of x minus 5. So this becomes y equals plus or minus 3 times the square root of x minus 5. Okay, everybody good so far? All right. And so I've solved for y, but I have to check domain restrictions. Up here, this was a quadratic, this is a linear. Those were fine. But here, this is a square root function. The parent function for a square root looks like that, right? I definitely have a restricted domain. This minus 5 means that I shift in which direction? To the right. I shift to the right 5, so it would look like that. Which means that my domain, I'm here at 5, it has to be greater than or equal to 5. I can figure that out graphically, or like if I put in 5 here, I get 0, it's fine. If I put in 4 here, I get negative 1, that's a bad thing. So my domain, x has to be greater than or equal to 5. That's my domain restriction there. So if I have a restricted domain because the graph looks something like this. If I substitute in 4 or anything less than 5, I'm going to get a negative under the square root. Then I won't get a real answer. It'll be imaginary, and I can only have real numbers for what I'm doing. Anything else? Okay. So let's look at number 3. Maybe number 3 was one we can skip. Hang on a second. I feel like I did too many last period. I need to do all those. Yeah, let's go ahead and do it just because it's something that happens in there. All right, so I would solve this one for t. So this is going to give me x minus 1 equals negative 4t. So then I would divide by, excuse me, a negative 1/4. So t equals negative 1/4 times x minus 1. Right. Then I'm going to substitute it in here. So I'm going to get y equals 2 times negative 1/4 times x minus 1 squared plus 5. So I'm really doing this one for more of an algebraic reason than I am for a parametric reason, because I know you know how to do this stuff, but maybe, we just need to think about what we're doing here. So I get y equals, I got this 2. When I square all of this, this is going to give me a positive 1/16 times x minus 1 squared plus 5. Then I can multiply that and get y equals 1/8 times x minus 1 squared plus 5. And this is a quadratic, so there's no restriction, and there's no restrictions up there either. Okay. Everybody good so far? Alrighty. Which one you want to solve for t in number 4? Y. I agree with that. So we will do, this will be y plus 7 equals 2t. So t equals 1/2 times y plus 7. Put it in here, and I will get x equals 1/2 times y plus 7. All that squared, then minus 3. Then x equals, that'll be 1/4 times y plus 7 squared minus 3. And I need to solve for y, so that'll give me x plus 3 equals 1/4 times y plus 7 squared, multiplied by 4. I don't want to square out that y plus 7, or at this point, if I'm trying to get that undone, I'm going to take the square root of both sides. So that will give me plus or minus the square root of 4 times x plus 3 equals y plus 7. And then I'm going to subtract 7 from both sides, and I can take the square root of 4. So this is going to give me plus or minus 2 times the square root of x plus 3 minus 7 equals y. At the beginning, that was a quadratic and a linear, so I did not have any domain restrictions. But here, this is a square root function again, and I do have a domain restriction. What do you think that would be? X is going to have to be greater than or equal to what? -3. Okay. What questions do we have? We all good? Yes, sir. It's plus or minus. You have two answers. It's both of them. Okay. Number 5. So on number 5, the algebra part of it is going to be the same. I'm starting with, this is a linear, this is a quadratic, so those don't give me any restrictions, bless you. But they gave me a restriction, so I have to take that into account. But I'm going to worry about that at the end, okay? So let's go ahead and work the rest of this. So I'm going to solve this one for t. So I'll get x plus 3 equals 1/2 t. So t equals 2 times x plus 3. And even though that's easy, I would still just leave it like that. It'll make your life a little easier in the end. So then I substitute it into this one, and I'm going to get y equals 2 times x plus 3 squared minus 7. So that gives me y equals 4 times x plus 3 squared minus 7. Okay. I feel like you're totally capable of that. We got to make sure we know what to do with the domain. So this is a quadratic, so there is no domain restriction for this, but they gave me one at the beginning. So in order for me to figure out what it should be here, this t, I've got to figure out what my restriction is for x. So since t is between two numbers, x is going to be in between two numbers. And the way I figure that out is I take this number, substitute it in for t in the x equation. So I'm going to get 1/2 times 2, which is 1, minus 3 is a -2. Then I take 8 and do the same thing. Half of 8 is 4, minus 3 is 1. And that's what I end up with. Okay, so you just substitute it into the x, substitute your t restrictions into your x equation, and then that gives you what your answer is. Okay. So on number 6, all I want you to do on number 6, just because I feel like I know you can substitute, I just want you to get me the domain restriction. So at the end, after we would find all this stuff, then find the domain restriction for x. Did you get between -3 and 12? Yes. So we all understand where to get that from then. Okay. Just wanted to make sure, because that's what makes that one different. Okie dokie. Let's look at number 7. So on number 7, they didn't give me a domain restriction. However, there clearly is one, right? T cannot equal what? 0. So here I know that t cannot equal 0. So then I'm going to figure out which one I want to solve for t in. I think this one. And these just end up changing places. So t is equal to 1/y. So then I substitute that in, and I'm going to get x equals 1/y plus 2 over 1/y. So I need a common denominator in my numerator. The common denominator in the numerator is going to be y, right? So this would end up being 1 plus 2y. In the denominator, I still have 1/y. I have a fraction and a fraction, so I'm going to multiply by the reciprocal of the denominator. So I get 1 plus 2y over y times y over 1. Those cancel out. X equals 1 plus 2y. Then you get x minus 1 equals 2y. So y equals 1/2 times x minus 1. T can't equal 0. When I substitute that in there, I just get undefined. So that just means that x also cannot equal 0. Everybody okay with all that? All right, so on number 8, they did not give me a domain restriction, but that's a square root function, so I have a domain restriction. I know here that t has to be greater than or equal to what? The 3. Yes. And so I'm going to actually solve for t in this one so I can get rid of the square root. So that means I'm going to get x minus 5 equals the square root of t minus 3. So then I'm going to square both sides to get rid of the square root, and I will get x minus 5 squared equals t minus 3. So t will equal x minus 5 squared plus 3. There's my t. Then I substitute it into the other one and get y equals 1/2 times x minus 5 squared plus 3 plus 8. Make sure you actually, in this case, I do need to distribute a little bit to make all this make sense. So this is going to give me y equals 1/2 times x minus 5 squared plus 3/2 plus 8. So y equals 1/2 times x minus 5 squared plus, well, if this is 3/2, this would be 16/2. So when I add them together, I'd get 19/2. That's a quadratic, but I do have a domain restriction because I had one up here. So if t had to be greater than or equal to 3, then x has to be greater than or equal to, I take the 3, substitute it in here, that'll give me 0, then I get plus 5, so it's 5. What questions do we have? Everybody good? Okay, so that's taking parametrics and putting them into rectangular. So now let's look at polar and parametric. Oh, and one thing I think I forgot to say at the beginning, dang it, is I do want you to have, if you have this handy, your trigonometric identities reference chart, grab that. I'll talk you through it, but it probably would be helpful if you could actually look at it as well, so sorry. It's wherever you saved it. You were supposed to have it handy somehow. So, okay. So the graph of a polar equation. So the graph of a polar equation, r equals f of theta, is the same graph as the parametric equations. X equals f of theta times cosine theta, and y equals f of theta sine theta, okay, where theta is the parameter. So instead of t, we have theta, right? And it says to write each polar equation as a pair of parametric equations. So if we're told here that r equals f of theta, and I have an r equals here, then that means here f of theta equals 3, right? If r equals f of theta has to be 3. And then to get these into parametric equations, this is going to give me x equals 3 cosine theta and y equals 3 sine theta. Everybody okay with that? That easy? All right. So let's look at number 10. So for number 10, our f of theta equals 4 sine theta. So I'm going to substitute in and get x equals 4 sine theta, because that's my f of theta. Then I have to multiply it by cosine theta. Look at, do we have anything on our chart where we multiply sine times cosine? The double angle. If you look down there at the double angles, you see sine of 2 theta? And it says on there that sine of 2 theta equals 2 sine theta cosine theta. So I can substitute 2 sine cosine theta for sine 2 theta. This is 4 though, so this is really like 2 times 2, right? So it's 2 times this, which would mean that x is going to be 2 times the sine of 2 theta. Everybody okay with why I did that? Where that came from? This is not magic right here. This comes from your trigonometric identities reference chart that you were supposed to have handy. Whether it's in your digital file somewhere or in your backpack or whatever. All right, so then we have y equals, so y equals f of theta, which is 4 sine theta, times sine theta. Well, what's sine theta times sine theta? Sine squared theta, so it's 4 sine squared theta. Any questions at all? Okay, so we've taken polar, changed them to rectangular, to parametric. So now we're going to take parametric and change them to polar. We're going to take the parametric and not change parametric polar equations and change them to rectangular. That's what I'm trying to get out of my mouth here. So write each pair of parametric equations in rectangular form by eliminating the parameter theta. So basically, I got to get rid of the trig stuff. So on these, I need to solve for the trig stuff. So I'm going to solve this for cosine by dividing by 3. So x over 3 equals cosine theta. Here I'm going to solve for y. So I'm going to get y over 2 equals sine theta. Right? So then I need to figure out how sine and cosine are related to where I know that I can multiply them and multiply by 2 to get sine 2 theta, but that still leaves me with some trig stuff. But I have a Pythagorean one that would really help me. Cosine squared theta plus sine squared theta equals what? 1. So now I just substitute. For cosine, I substitute x over 3 squared plus, then I substitute y over 2 squared, and that equals 1. I'm not going to have to solve for x or y here on these, but I do need to clean it up some. So this would give me x squared over 9 plus y squared over 4. That equals 1. And that's your answer. And on these, we don't have to worry about domain restrictions either. Okay. Everybody good? All right. So then you try number 12. Any questions on number 12? Easy enough? Okay. All right. So let's look at number 13. 13 and 14 are just a tad bit different, just enough different that I want to work them here. So this is already solved for sine. I solved this for cosine, so I get y over 4 equals cosine theta. Okay. And we know that whether it's cosine and sine or sine and cosine, that sine squared theta plus cosine squared theta equals 1. Okay, so there's a reason I'm rewriting it again where I didn't on the last one. X is equal to sine squared. I don't have to take the square root to get sine. If x is sine squared, I just substitute it directly in for sine squared, and I'm not squaring it. But this is just cosine, so I do, not equals, I'm sorry, plus. Then I need to take this, and I do need to square it. So that'll give me x plus y squared over 16 equals 1. Everybody with me? Why x is not squared? Okay. So on here, when they're both squared, you don't solve for either one of them. Here, we at least need to solve for y squared. So this will give me y squared over 16 equals 1 minus x. And then y squared equals 16 times 1 minus x. And I can just leave it like that. I don't have to take the square root of it. And we don't have to worry about domain restrictions on the polar ones. Okay. All right. Any questions? Because they weren't both squared. Does it make sense? So if they're both, if x squared and y squared, or did you say why didn't we or why did we? Why did we? Okay. I guess why didn't we take the square root as a different, okay, because these are both squared, so then you don't, because that's just the nature of those functions, or they're not functions, the nature of those relations. And here we're just trying to get y by itself. Since only one of them's squared, then you go ahead and make sure you get y by itself. You can leave it as y squared on the polar ones, yeah. Anything else? It's a good question. Okay, so here, this one's already solved for cosine. This is cosine 2 theta. So that's why we need to look at this again. Or again, if you didn't happen to have it with you today, because you didn't think you'd need it, I'll just talk you through it, but you got to be able to find it eventually. Cosine 2 theta is the one that we got 3 choices, so I got to think a little bit. If I'm going to try and substitute stuff and actually get rid of all of the trig stuff, then it would make the most sense for me to use the one that only has cosine in it, since this has cosine right here. So I'm going to make this x equals 2 cosine squared theta minus 1. So I just substituted cosine 2 theta from my trigonometric identities reference chart. No magic there. Then I can go ahead and substitute this in, because if y equals cosine theta, then I can substitute the y in right there and get x equals 2 times y squared minus 1. And then once again, I'm just going to solve for y squared, so I get x plus 1 equals 2y squared. And then y squared equals 1/2 times x plus 1. And I'm done. What questions do you have? Anything at all? We're good? Awesome.